Question 1, we are supposed to construct a triangle with 3 given sides. So I'm demonstrating how to construct a triangle like this, and then the second part we will do a perpendicular bisector. First of all, it's like this. You will sketch the DEF. So we sketch the triangle. Then after that we label what is given on the triangle. Then after that we know what to draw. So you can start with a DF right here, which is 7. Then we use the ruler and we use this to measure 7.5. So DE is 7.5. So we make an arc here. Then EF we know is 5. So we will find 5 centimeters here. And then we just draw. So you notice that the two arcs don't match, so they don't intersect each other, so I have to go back and then find 7.5. And then we just extend the 7.5. So then you get this cross. So this will be your point E. So this is your DEF. So the part 1 says that you have to measure the size of the smallest angle. The size of the smallest angle will face the shorter side. Then the largest angle will face the longer side. So in this case, we will measure the side that is facing the smallest angle. The smallest angle is this one. Then we take a protractor, then we measure this. So we take a protractor and we measure the smallest angle here. So this is about 40 on the protractor. Okay, so the smallest angle, which is FDE, will be 40 degrees. Then second part, we have to construct the perpendicular bisector of DE such that it will cut, and it will cut FD at point H. So perpendicular bisector is like this. You will use this, then you measure more than half of this length of the DE. Then we make an arc this way, and then we go to E, and then we do the same arc. So this will make the two arcs will make two crosses over here, one on top and one below. So we just join, and then the pink line will be your perpendicular bisector of DE. So then the point that cuts FD, which is this point, will be H. then you're supposed to measure down DH, so it's about 4.9 or 5. So 5 centimeters. Okay. The second question, we're supposed to construct a triangle again. So this triangle is given 2 sides and 1 angle. So same goes, I would just sketch out whatever I have. So I will draw a triangle GHI again. I just a rough sketch so that I know what to draw. So GH is 7.1, then HI is 5.6, then GHI, the angle is 83. So we draw this. So I will start with a known line. So I start with GH. So GH is 7.1. So measure 7.1. So GH. Then because GHI, I is around here, and then there's angle 83 there. So I'll take the protractor and measure 83. So 83 is about there. Is about that. So what I do is I will just connect first. So then I know HI is 56. So I'll 56, 5.6. So take the ruler, measure 5.6. Then I will mark I with an arc. So then this would be I. Then I complete the triangle by drawing a line from this intersection to the point G. So this is triangle GHI. This is 83 degrees. So part 2, we are supposed to draw a perpendicular bisector or GH. So you should know how to draw a perpendicular bisector by now. So again, the arc should be longer than half of GH. So I make 2 arcs. Then with the same arc length, I make the other side. Then it makes 2 crosses. So I connect the center of the cross to the other center. So this is the perpendicular bisector of GH. How you check whether the perpendicular bisector is correct is you have to measure the 2 lengths. Say here, this is about 3.5 plus a bit. Then this is about 3.5 plus a little bit. So if the two sides are about the same length, then and then of course perpendicular bisector, you need to use the set square to measure whether this is a right angle. Using the corner of the ruler is fine too. Then if all criteria is meet, then your perpendicular bisector is correct. Okay, then you go to the angle bisector of GIH. GIH is this angle. It's supposed to draw a angle bisector now. So you adjust this to any length that is easy to maneuver, and then it doesn't overlap with the earlier arcs. Okay, because if it overlaps with the earlier arcs, then it's gonna be difficult to differentiate lah. So I adjust to a suitable length, then I create an arc. See, the angle is here, then I will create an arc on the line of on the side, right, where where the two sides will actually make the angle. So like this, there like this. So I make two arcs already, or one on each side. Then after that, I put this onto the intersection of the line and the arc, and then I continue one more time. So here, and the same thing I do to the other side. So you make a cross down here, so I will connect the point I to the cross there, to the center of the cross. Then you get this one is the angle bisector. Then this one is the perpendicular bisector. So then for the next part, I have to explain a little. So let's talk about a perpendicular bisector. Okay, sorry, it's not very bisector right now, but yeah. So let me add a bit. Okay, so A, B. A perpendicular bisector is like this. So it cuts the line AB. So any point on this side is closer to point A, and any point on this other side is closer to point B. Okay. Then if I have an angle bisector, so we have an angle, so say A, B, A, C. So this is the angle. Any point on the top part of the angle bisector, this part will be closer to side AB. Anything that is under is closer to side AC. So if that's the case, right, so we use this knowledge on part 4. They say mark clearly a possible point which inside the triangle which is equidistant from G and H, and then nearer to GI than HI. So when they say there is an equidistance from G and H, right, means it's on the perpendicular bisector, means the point is on the perpendicular bisector. And that means it's anywhere along this line. Then it is nearer to GI than HI. So nearer to GI than HI, that means it's on this side. So it's on here and then on the line. So I could say that the any point here, any points along the perpendicular bisector and it's on the other side, closer to this side, the shaded place, then these could be possible points of P. So the third one is we have the same type of triangle again, so I make a quick sketch. So it's PQR, then PQ is 6.3, QR is 4.9. So same as the earlier question, so I'm not gonna make too much explanation here. So PQ is 6.3. Then we measure a 57. Then we make a line. Then QR, R is over here, R is 4.9, so 4.9. So I make that up here. Yeah. You say the point O is such that it's equidistant from all three sides. Means we have to construct three angle bisectors. Okay. If it's equidistant from 2 points, then we draw a perpendicular bisector. So if it's equidistant from all 3 points or 3 vertices of the triangle, then we draw 3 perpendicular bisectors. But this one says that it's equidistant from all 3 sides, we will draw 3 angle bisectors. So it means I have to angle bisect PQ and R. So same goes. So I'll start with the angle bisector of Q. Then angle bisector of P So this will be done in pencil for most students when they do the question. So they have to differentiate the angle bisectors. Then now angle bisector of R. Angle R. So it's this. So the point where all three sides, right, equal distance from all three sides will be this point. Question 4 is a little different. Now we are going on to a parallelogram. So for the next few questions, they are all drawing quadrilaterals, four-sided shapes. So same goal, so I have to first draw a parallelogram. Pardon me if the drawing is terrible. So A, B, C, D. AB is 4.8, then BC is 5.5, then BAD is 68. So I have these. So we do notice that if it's a parallelogram, if opposite sides are of the same length, so DC is also 4.8 and BC is also, AD is also 5.5. So we will start with a known length again. So start with AD. We measure 5.5. Then we measure a 68. Okay, I am doing this at an angle, so 68. This doesn't look like 68. Yeah, it is 68. Okay, so I'm doing this at an angle for camera sake. So there may be parallax errors and all that, so do pardon me. Okay, then I have to measure a 4.8 because the point B. 4.8. Like this. So the other thing is, you know that C would be, this is point B here, C will be somewhere here and it's 5.5, and there's a C here from here which is 4.8, so I can draw another arc 4.8 here. Sorry. So there's a 4.8 here, then I measure a 5.5. So measure 5.5 here. So then this is your point C. Then from here on, I can just connect all the points, all the lines to this point here. Then it's supposed to measure AC, so AC is about 8.5. Then second part, they say they want the perpendicular bisector of AB. So cuts CD at E. Okay, so perpendicular bisector more than half of the line. So you get this. It cuts through CD at point E. Okay, so measure AE. AE would be 5.6. Okay. Then you have this one, you have trapezium. Trapeziums typically look like this. They have two parallel sides. Then they say AB is parallel to BC, so we kind of know ABCD. Then BAD is 83. Oh, so it's a bit out. AD is CD is 3.6. Okay, my sketch is a bit reversed. Okay. So we start with my 3.6. 3.6 is over here. DC. Then because this is 83, so we know that this is 180 minus 83. $97. We can draw an angle 97 over here. So 97. So AD is 6.2. So we take this measure 6.2. Then there's 83 over here, so I will measure 83. So it goes this way, it's a horizontal line. Then you know that AB is 8. So AB is 8, it's about this. So this is B here. Then we can connect B to C. This is 83, this is 97. Then we're supposed to measure BD. So BD is about 9.5. Okay, question 6. This is the second last question. Question 6, we are doing a quadrilateral QRST. So no idea what's QRST, so anyhow we'll draw QRST. QRST. So then label, this is 8. QRS is 118. RS is 7.5. QT is 10. Diagonal RT is 12. So that's a lot of information. Again, we start with something we know. I would like to put QT as a horizontal. Or should I use RQ? So I will use QR as the horizontal. So QR is 8. This drawing may be a bit big, so I'm gonna put it further down. QR is 8. So there is a 118 here. This is 90, 100, 110, 118. Then you know RS is 7.5. So take this, measure 7.5. So you have to extend this line a little because it's 7.5. So this is QRS. Then we know T is over here and is 12 centimeters away and 10 centimeters away from here. So I measure 12. From R. So I make an arc 12. Then QT is 10, so I measure 10. So this is T. And then we will join S to T from here. Like that. So this is the quadrilateral. It's quite a big drawing. So then B part 1, we are supposed to draw the angle bisector of TQR. TQR, so we will bisect this. So method is the same, so I shall not elaborate. So get more than whatever I can maneuver. So here then here. This is B part 1. Perpendicular bisector of TQR, wait, perpendicular bisector RS, sorry, RS is over here, so more than half. This works. So it's this point, this point. Okay. Mark and label the point of intersection of the constructor line with the point V. So this is the point V. Then you measure QV. QV is about 8. And last question. Question 7, we are doing a rhombus. Rhombus is a 4-sided shape that looks like a parallelogram, but all 4 sides are the same length. So A, B, C, D. AB is 7, which means everything else is 7. Then it says ABC is 60, so 60 here. Quite easy, right? If it's 60 here, that means this is 120. So I'll start with a base of 7. So A, B, C. C is up here and it's 60. So I can draw this. Then I have to figure out 7 centimeters. So 7 centimeters. So this is point C. So D is over here. Thing is, you know that this side, this length is 7 and this length is also 7. So I will just use 7. I draw 7 here, an arc. Then I will draw another 7 here, which is another arc here. And I will locate the final point D. So this is 7, this is 60 degrees. Yeah, that's ABCD. Then angle bisector of ADC, this angle. So same method. Something that I can maneuver easily. Draw 2 arcs like this. Like that. So this is the, connect this to this. This is the angle bisector. B part 1. Perpendicular bisector AB is over here. Over here. So a length which is more than half. More than half here. Then like that. So this is B part 2. The perpendicular bisector intersects the angle bisector at X. So this is point X. Write down BX. So BX is over here. It's about 4 centimeters. That's all.